Welcome everyone to the worst possible time slot to present at a conference, the 2:30. Everyone's kind of post-lunch crashing. You haven't started the second round of caffeine. So thank you all for being here. Couple of minor changes to what's in the agenda. I'll go over that in a second. The first is I was supposed to be co-presenting with a guy named Danny. He is not with us. Needless to say, he's not dead. He's just at home. He's got a family issue. But he did leave me high and dry to present by myself, so he's dead to me going forward. I see Rod back there taking a picture. That's going to find its way to Danny within about 30 seconds. Yeah, exactly. It's like, so you're stuck with me. So who am I? I'm a director of engineering at SUSE. My name is Jason Dobies. I work in the Edge team. I've been here for about 2 years now. It's honestly probably the single best engineering team I've ever worked on. These guys are awesome. They're incredibly smart, incredibly fun. I've been working with Kubernetes for about 8 years now, and I've been working with Linux. I look at this audience probably longer than some of you have been alive, which is equal parts kind of cool and also really, really depressing. So what are we going to talk about today? It's kind of weird to do a demo this way, but I want to, and this is again one of the changes from what's listed in the description on the site. We're going to demo booting up a Raspberry Pi and with no further interaction, having it start up a Kubernetes cluster and automatically deploy a workload for us. Now, a couple of these pieces take a bit of time, so we're going to jump back and forth between demo and live stuff. Again, it's going to make it a little awkward to show you something before I've told you what it was, but we'll get through it. In the middle, we're going to talk a little bit about what brings us here today, what inspired this project, and then what it actually is. Excuse me. So the very, very high-level overview of the demo and what we're talking about today is a tool called Edge Image Builder. The idea is we have a stock SUSE Linux Micro installation, or I'm sorry, image, either a RAW or an ISO image. And that's cool, but we don't want to do any post-installation setup. We want it all to happen the second we boot the machine on first boot to get everything running for us, the zero-touch of the zero-touch provisioning. And then, like I said, we're going to burn that onto an SD card and boot it into my Raspberry Pi that thankfully got past US TSA security and didn't cause me any problems. So what you're looking at right now is the tool running. A couple of basic things to give you an idea of what you're looking at. This is deployed and runs as a container. So the installation is basically get Podman running, and then you're good to go. It's doing a series of steps in there that we'll talk about much later in the slides. But for now, understand, you'll see things like the artifact registry getting populated. That is where EIB goes and downloads the user workloads we have for Kubernetes, writes them to a drive that's going to get written inside of the raw image itself. It's also downloading K8s itself. It's running a couple of customizations on the image. It's just a small subset, given it's a Pi and there's not a lot of time. We'll see the full feature set. But again, the takeaways here. It's a CLI. It is going to take a version of, a download of SLE Micro. It's going to customize it to make it have everything you need. So out of the box, the second you boot it, it is ready to go. So we're going to let that bake, and we'll hop back to our slides for a second. Now, if you've seen any of the other Edge presentations today, I don't want to spend a ton of time on talking about what the Edge is. I could tell you that it's not the data center. It's a little obnoxious to say we solved the data center, but we figured out a lot of the data center problems. There's Ansible, Puppet, Chef Salt, a variety of food-themed configuration tools. We've had this kind of answered for a while. Similarly to the cloud, we've had a lot of that answered for a while. There's dozens of tools out there for file-based provisioning and doing it through a CLI and so forth. So what is the Edge? Pretty much everything else. So very irrelevant story. This May, I will have me married for 20 years. I have an amazing wife and 2 great children who are completely sick of me on vacation as I point out that's what Edge is, and that's what Edge is, and that's what Edge is. They're not technical. We're universal. They're muggles in the Harry Potter parlance. So we went on a cruise, for instance, and I'm sitting there pointing out the kiosks and the cameras that they're going on and the different sensors. The damn water slide's got like a sensor telling you when it's free to go. I'm like, all of this stuff is edge. And they're like, Daddy, I don't care. But that's okay. Like I said, everything that is edge, everything outside of the data center is largely what we consider edge. And there's further different ways we could break it down from there, but I'm not going to get into it for the point of this talk. I will have time for Q&A at the end of this. I want to answer one question right now that I know most of you are thinking. 2 slides ago, I had a picture of a food mixer. This slide, I made a reference to pies. And you're probably thinking, is he really going to beat this whole pie metaphor to death? You bet I am, so buckle up. So what are the difficulties we face at the edge? What made us create this type of product? I'm stupidly proud of these. They're so dumb compared to like Basil's this morning, all professional in marketing. I'm an engineer. This is as good as you guys get. So low bandwidth situations, satellites, even cruise ships, if you think about what they're getting connection to. How do you provision these systems? How do you take these beefy operating system images and all of your workloads and subsequent updates? How do you get them out to an environment where you have these very low bandwidth confining restrictions in place? I take it back. This is the slide I'm most proud of. This is as lazy as they come. No low bandwidths. No, I can't say that in a conference. Evil step cousin, no bandwidth, or thank you for seeing where I was going with that. Air gapped, no bandwidth situations. So either full air gapped or just a localized network where you don't have access to the public internet that has all of the same complications of low bandwidth, but really ratcheted up to be much more difficult. You have all of the problems of vetting the bits before they manage to get in there. And again, you still have all of your delivery problems of getting them to the machines and getting them started up. The no bandwidth situation also presents a real hiccup to your Ansible-based solutions, where you really expect to have connectivity and be able to give it all these commands and say, install this, and now provision this, and set this up. Scale is one of the cooler aspects of working at edge. It's also one of the bigger pains, because we're thinking in tens of thousands of nodes, if not more. And that complicates quite a few things. When it comes to building an image like this, we knew out the gate that we could not rely on our customers to build 35,000 distinct images. That was never going to fly. So we needed a tool that was going to be able to build a single image that you can use in multiple situations. And depending on where it finds itself, it's going to do the correct thing in terms of setting up networking and clusters and high availability and so forth. The edge, one of the main areas, is retail. Grocery stores or coffee shops, where you don't necessarily have an IT staff that you can give complex instructions to on how to set things up, how to go through the steps of the configuration, how to debug it. You need something that you can prepackage all this information and get it out to these remote sites and not really expect to have someone with a ton of IT experience on site to be able to install it for you. The other side effect of these scenarios is they're not the most secure. Got a bunch of college kids serving coffee. Your servers are in a back room somewhere. So now we need to, out the gate, encrypt the disks and add in a bunch of compliance and security features, because there's a very real possibility the servers just kind of got to get up and walk out of the building. Again, not the data center. We don't have a lot of the comforts that we've come to appreciate there. And there's just straight up no staff whatsoever. Cell towers is the biggest example here. Prior to this job, I never really thought of it. I would have some kind of like low coverage area and I'd be pissed off like everyone else, and I didn't think about the complications of it. But you don't have all of the cell towers manned. It's just not possible. You also have in these very, very remote areas. So they need this ability to, I shouldn't have made it animated. This is freaking me out every time I look up. You need this ability to package up everything you need, get it out to those sites, and do it in an automated fashion. Last but not least, the edge is not, in fact, delicious. OK, demo part 2. So by now, I'm hoping I've given enough time where the image is completed and has written to an SD disk. It has. What I'm going to do is take the, I have plenty of time. Take the SD drive and boot up the Raspberry Pi. There we go. Hopefully this is kicking in. Cool. Again, we're not going to watch this whole thing. I just wanted to make sure it started. What we probably missed before the video kicked in was SLE Micro menu. If you've ever booted SUSE Linux Micro, you get that initial, do you want to start the system? If it hadn't been installed, that first entry point would have been install. We skipped that because we have this pre-built image that has all of these customizations in it that negates the need for that installer. It basically gets past it. And that was one of the bigger things we had to answer. When you first boot Micro, by default, it's going to ask you, do you want to install it? And that's going to sit there and wait for an answer. Problematic when you're dealing with half the scenarios we just talked about. You don't have someone on site that can press enter. You have too many machines where you don't want to have someone who has to press enter each time. You also have to configure which disk you want to write it to. Very simple stuff. It's literally just enter, enter, but that's not sufficient at the edge. We don't necessarily have the ability to always do that. So all of that is taken care of. The Pi is going to start booting. I'll come back to what it's actually doing in a second. So what is Edge Image Builder? We already established it's a tool, it's a CLI tool, runs inside a container. So again, installation, very simple. I'll talk about the platforms it runs on in a second. But the way it functions is it takes an image definition. This is a simple YAML file that says all of the stuff I want to include in the image, from the customizations to extra features I want to install and so forth. The configuration files is just a simple directory. And that's going to give you the opportunity to drop binaries in place, existing configuration files. And I have a quick snapshot of one in a second. And then our SLE Micro, which actually it's technically 5.5 and beyond it supports. But you start with a base image that you've downloaded already from SUSE. The real-time kernel or the regular kernel both work. Put them all through Edge Image Builder, and what pops out on the other side is either a raw image or an ISO image, which is what was kind of hidden behind that demo, but is what we wrote to the D drive. Don't know how well this looks. I also don't expect you to read a whole bunch of YAML during a presentation. But I wanted you to at least get an idea for what we're looking at with this image definition. I see some things on there, some basic stuff you'd expect to find. Architecture, the name of the base image we're building off of. At the bottom, you see I configure root with a very secure password, EIB, which you'll see me type in about 10 minutes. And then there's a handful of other things. In this case, we're saying I want to install Kubernetes. We give it a specific version. This version is going to be K8s. And then I provide a URL to a Kubernetes manifest. The Edge Image Builder, when I ran the demo, went to that URL, downloaded the manifest, analyzed it, and downloaded the image for, take a picture? Oh, you got that. Manifest. So downloads the container image and stores it on our built image. Raw configuration in there is just resizing it. I ended up going through this line by line. The point I wanted to make in this is a simple text file. That means all of your existing GitOps behavior, all of your behavior for treating anything as text, infrastructure, whatever, this fits very nicely into all of those. It can be version controlled. You can have your accountability. I'm a part-time teacher. I love teaching my students Git blame because they love the idea of being able to point at their teammates and say, you're the one who broke this. We support that. You're the one who broke this. Configuration directory, like I said, is everything that doesn't really fit into the definition file. We start at the top with the base image. Raw ISO downloaded from SUSE itself. And there's a variety of things you can put in here. You'll see some custom files, and I'll talk about that. Actually, I have slides on most of these. Few things to point out. If you've ever used Elemental, integration with the inventory function of Elemental is very simple. You take the config file that Elemental provides for you, you drop it in the correct directory, and when your node boots up, poof, it registers itself with Elemental, life goes on. Kubernetes, you can drop the specific server and agent configuration files in there that you want deployed out there. There's additional ways in the definition for a multi-node Kubernetes to say which ones you want as your control plane versus which ones you want as your workload nodes. Sorry, just mini stroke. And manifest that you want, so you don't necessarily have them hosted off of the URL. You can include the manifest in there, and it'll again automatically put those in. Networking. I'll talk about networking when we get to that slide. So platforms. We support running on x86-64 and building x86-64 images. Similar to running on ARM, you can create ARM images. We don't yet have cross-architecture. It's something that's on the roadmap, which I'm just going to leave it at that. Like I said, we haven't exactly prioritized it yet. There's a lot of things on the roadmap, but that is something we have our eye on. The ARM support is technically tech preview right now. It has been since Edge 3.1, looking to fully GA it by, I want to say 3.3 or 3.4. I apologize, I forget the number off the top of my head. Down here I have a link. I just remembered to drop it in at the last minute. I'm sorry I didn't provide a QR code. One of my teammates wrote an awesome article about a month ago, on doing very, very similar to this demo. It's a little more fleshed out, but on your Mac. So it's still an ARM-based demo, but it's going to be simpler than carting all of this crap around with you and running on a Raspberry Pi. I'll leave that up for another second for those of you who want to take a picture of it. Again, this is just on the SUSE blog in case you need to find it on your own later. So the operating system. I'm not going to lie to you, this is a very boring slide because reading off a whole bunch of things you can configure on an operating system is itself inherently boring. However, user credentials. Users, groups, SSH keys, passwords, anything you would want to do where, and you'll see it in a second, I need to be able to log into this machine. I really don't want the default micro password just floating around in the wild. That is, hope I don't need to explain to the room. That's a generally bad idea. I'm seeing some nods, so good, come with me on this. All of your time settings, your NTP servers, things like that. Your system D management. So you can enable and disable system D services. There's a few that are commonly disabled by our customers. I'm not going to say it's any kind of default because we don't enforce it, but there are a few that some of the customers don't particularly agree with the default configuration. Completely fine. We have the ability in this definition to say, I want you to turn off Reboot Manager, and I want you to turn on some service whose name I can't think of on the fly. Additionally, kernel arguments. This was very important for our telco customers. They customize the living crap out of the kernel to extents that I don't even fully understand. I just know how to take those kernel arguments and make them usable. We have a presentation tomorrow on something like that. I read the guy's slides. He's brilliant. I don't have a clue what it said in there. Name's Alberto. Awesome presentation. Go see it. If you've learned anything from it, tell me because oof, over my head. I already mentioned raw and ISO builds, and then FIPS compliance. Again, Edge, we have a lot of these, quite frankly, painful outside influences. Air gapped is one of them. All of these compliance standards are another big one that, you know, I say it negatively, but I say that as an engineer who had to implement this. These are all good idea features. It's just when you're the guy doing it, it's like, wow, this is really a giant pain. RPMs in particular, speaking of giant pain, we have the ability to specify not just, hey, I want these RPMs installed, but again, we're catering toward these air gapped and these low bandwidth situations. So we want to have all of those bits for the RPMs embedded inside the image. So that way, on first boot, combustion kicks in, and we'll take care of installing all those RPMs for us. Let me quickly tangent, because I think I forgot to mention combustion is the tech that runs all of this. Combustion, if you've never heard of it, it's one of the, again, like this industry works, a couple of different ways you can have first boot configuration happen. We lean into combustion pretty heavily. A lot of what Edge Image Builder does is create a combustion directory. It executes on first boot. It runs basic shell scripts, which is really nice in a lot of ways. We've had a lot of flexibility come out of that. Edge Image Builder generates a whole bunch of those scripts, runs them as necessary, so that way when the image first boots, and we don't see it because the Pi's not plugged in right now, but you could see it executing all of these steps and doing all the configurations we talked about. Okay, back to RPMs. We're still talking about the problem that we need these bits directly in the image for our air gap situation. We can't simply say, okay, cool, if they want RPM X, we're just going to download it because RPM has all sorts of fun dependencies. A mediocre developer of mine managed to stumble through getting the, he's right there, he's actually brilliant. I'll give you the serious pitch. No, he actually found a really clever way of prefetching all of the dependencies. So if I simply say, I want this image to have installed RPM X, Edge Image Builder will figure out these are all of the dependent RPMs that are required for it, download those and well include them on the image. Thank you, Evo. I don't look at him directly right now because when I bring this stuff up again, he gets into cold sweats and he kind of is going to go quick in the corner because it was very painful to do. But it's very awesome. Okay, networking. I want to point to this bottom part first, the one image, multiple nodes. I loosely alluded to it earlier when I was talking about the scale question. And if we have 35,000 nodes, we do not want 35,000 images. That would pretty much be a non-starter for all of our customers. So we have a networking configuration in place that you can define in a number of different ways how you want networking configured for multiple nodes that are going to boot off of the same image. One of the approaches is as you would expect, MAC address based, where I can say, if you find this MAC address on the machine, this configuration, and so forth. There's a handful of other options, including a very transparent's not the right word, but we basically just give you free access to the underlying network and say, you do what you want. If you can't go through the setup, we have the facade to make it easier. Cool, you can lay down some configuration options. Back a couple slides ago, when we saw the image configuration directory, there was one file per node that was getting configured. Again, that is a single option, but it lets you do pretty much what you would expect to do. The key point, again, one image. I've done a version of this talk without the Pi for a HA cluster where it's the same image, and as it boots up, you can see that it's assigning the correct IP to each node. Kubernetes, obviously very important to us. There is, Basil alluded to it in his keynote today. SUSE is really looking to unify kind of across all of its offering. We've got some amazing Lego pieces going on here. And now we want to go and take that and piece them all together. This is another part of it. I've been talking in terms of SUSE Linux Micro the entire time. Kubernetes is also a massive part of the story. So being able to tell Edge Image Builder, hey, I want you to pick, or I shouldn't say pick, you choose, and you tell Edge Image Builder, I want you to install K3s or RK2. Here's the specific version. Here's the configuration for it. And most importantly, here's the workloads for it. Because just getting a cluster out there is cool until you realize it's not doing anything. Talked a bit about it earlier. Those workloads can come through either Helm charts or Kubernetes manifests. It will prefetch all of the container images as necessary, host them on the node itself, so that way when it boots up and when Kubernetes finally starts, it's going to apply the manifest, apply the Helm charts, use the bits that were already pre-downloaded to the image, and get those workloads up and running for you. I talked a bit about Elemental earlier. I'm also going to mention Suma. Again, one company, a lot of cool products. Let's make them all play with each other. So there is integration abilities for both of these where if you have an existing environment that uses Elemental, you can set it up where the node will call itself back. I'm sorry, call back to Elemental and register itself. And then the last catch-all, custom files and scripts. Remember how I mentioned everything is based on combustion? We knew we are a small team. This is a very, very new product, so we knew we weren't going to get everything out the gate. So the kind of escape hatch for anything that's not directly provided as a first-class citizen inside of Image Builder, you can add on your own through the use of custom scripts that will run at combustion time. We give you instructions on where to integrate with them and kind of the timing where they're going to execute in the sequence. We've had our stack validation team who is responsible for setting up much more customer real environments internally, use this extensively for all of the weird things that they're doing for their individual setups. It's been a great, like I said, kind of escape hatch for anything that we haven't managed to include as a first-class citizen directly in Edge Image Builder. Gives us the ability for people to come in and have their own customizations on top of it. And lastly, we are flying. We're going to get through this early. I'll leave this up for a second. It is an open source product. The link is up there. The QR code should hopefully link to it. I hope my desire to introduce Pi yet one more time into this presentation didn't break it. But it's an open source product. Feel free to file issue requests on there. Feel free to submit PRs open source. We're always happy for more help because we never have enough resources to do what we want to do. And that's also a good way to contact us if you go to use it. On there, you'll see a image building guide, which talks you through much more of the details that I glossed over in the slides. There's considerably more that's capable. It's just very hard to sit in a presentation and tell you a feature list for 20 minutes without getting completely boring. So with that, let's hop back to our demo. By now, I am hoping the system has finished booting. We should see the prompt. We do. Apologies, this one I don't know how to make any larger, so you're just going to have to bear with me for a second. I also don't really know how to not awkwardly face my back to you. So what I did was a quick curl command on a URL. That URL is hosted by Kubernetes on the node itself. Because like I told you guys, I was going to beat this joke to death. It is the recipe for an apple pie. You're all very welcome. Where's the actual point to this? Oh, okay. So this is the cool part. What you all saw was I did nothing. I plugged in an SD card and waited a little bit for the pie to boot. I simply logged in at the end just to be able to show it to you. But realistically, I didn't need to do that either if I had fully configured this and it was connected to a real network. But what happened in that time? The machine booted, kicked off combustion, which put off a whole series of customizations on this newly installed instance. It did, in fact, configure a network, even though I just have it connected to an empty router here. It set the root password so I can log into it. It installed K8s. It installed a manifest of my own with this pre-downloaded image, and that's just a subset of what it could have done. With a little more configuration, very minimal, I could have taken this same image and booted it multiple more times and set up a full HA cluster. I could have customized it to include more RPMs. I could have done a variety of things with my own custom scripts based on what I need. The important part, especially for a Raspberry Pi, is I wouldn't have to carry around a stupid keyboard with me from New Jersey because I could have it all baked into the card and just automatically run when I boot. We'll move back. Very good. Thank you all. Enjoy the rest of the conference.